Concepts of shaft alignment. The basics. In the U.S., millions of motors are coupled to millions of pumps. In addition, there are many other examples of rotating equipment that require shaft alignment. The shaft in the motor or engine rotates and drives the shaft in the pump or other driven machine. Misalignment of the shafts puts strain on both the motor and the pump. It can damage the bearings, the couplings, and other machine components. For this reason, manufacturers of rotating equipment have established tolerances defining the maximum acceptable levels of angular and offset misalignment for their machines. If two shafts are perfectly aligned, they are said to be collinear. Collinear means that a single straight line will define the center of both shafts. Of course, this is almost never the case in the field. Shafts are usually out of alignment, with the misalignment taking two forms: offset misalignment and angular misalignment. What we usually see in the field is a combination of both offset and angular misalignment, occurring in three dimensions, as you can see here as we rotate between the vertical plane and the horizontal plane. While it is much easier to understand misalignment if you can visualize it in three-dimensional space, correcting misalignment only requires that we get the shafts to align in the vertical plane and in the horizontal plane. Fortunately, we're able to adjust the relative position of the two shafts in these two dimensions. We can raise and lower the movable machine in the vertical plane, and we can move it side to side in the horizontal plane. If we get the shafts aligned in these two dimensions or planes, they will then be in tolerance and close to collinear. The challenge of precision alignment can therefore be defined as, first, measuring the misalignment in the horizontal and vertical planes; second, calculating the moves required to correct the misalignment; and finally, making the prescribed adjustments. So how do we measure the misalignment? That's the subject of our next video. Concepts of shaft alignment. Measuring alignment.